Hey everybody, we are starting the last chapter. Although the last chapter is split into two different parts. So you're going to be taking two tests on this last chapter. So we're starting with, the whole last chapter is all about right triangles. Because you're going to be using right triangles a lot when you get to integrated 3. Second semester we use a lot of right triangles. So it does come in handy for that. So we're doing geometric mean. So let me switch to just this. There we go. We're doing geometric mean today. So geometric mean is used to find the lengths on a triangle. Okay. Now, the geometric mean is a formula. X is the mean between A and B. So you put the mean in two spots. We have a proportion. That's two fractions with an equal sign in between. So the mean goes there and there. They go diagonal to each other. And then the other two numbers go, the two numbers that it's between go in the other two spots. So the geometric mean between, X is the geometric mean between A and B. X goes in two spots. A and B each get one spot and they're diagonal to each other. You can write it differently. Okay, you have two fractions on either side of an equal sign. You can have X be here, and you could put A and B in those two spots. As long as whatever your mean is, your double number that gets written twice, goes diagonal to itself. And then what you're going to do is cross multiply and solve. So, example 1. Find the geometric mean between 12 and 15. We don't know the geometric mean, so let's set it up. The geometric mean, we're going to do a fraction. Okay? Two fractions with an equal sign in between. The geometric mean is what we need to find. That's our variable. You pick a variable for geometric mean. I usually use X. So you put X here, and then the two numbers, 12 and 15, go in the other two spots. So 12 goes here, 15 goes here. Okay, that's setting it up. So this is your equation. Then you do the cross multiply. Cross multiply means you're going to multiply diagonally across. So X multiplies by X. So you get X squared. Then you put an equal sign, because once we cross multiply, there are no fractions. So X squared equals, and then we have 12 times 15. We multiply diagonally. Okay, so 12 times 15. We could actually multiply that out. I just wanted to show you what you do. So I get my calculator. 12 times 15 equals 180. Okay. So I have 180 here. Well, that's X squared, and we need to know what X is. So to find out what X is, we do the opposite of squaring. We've done that before. The opposite of squaring is a square root. So we get X equals. Now, if the question asks for a decimal, the nearest tenth, the nearest hundredth, the nearest thousandth, three numbers after the decimal, whatever it asks for, you would use a calculator. Most of the questions, I want to say all the questions, but I'm not going to make a guarantee of that. All the questions ask for simplified radical, which means we have to break out. So 180, well, it's 12 times 15. So 12 and 15. 12, it's 3 and 4. Remember to cross them out when you're done with them. 4 is 2 times 2. You want to cross out the 4 so you don't accidentally reuse it. 15 is 3 times 5. Cross out the 15. Alright, so remember our pairs break out. Pair of 2s, pair of 3s, and then this poor 5 has no pair to break out with, so 5 is still left behind. So our official answer, 2 times 3 is 6, because when we break this down, it's unmultiplying. So when we put them back together, we would multiply, right? So 2 and 3 multiplies because they're both out, and then the 5 is left behind. So x equals 6 radical 5 would be your official answer. So that's finding the geometric mean. Now, a lot of times you're going to have to find values on a triangle. Let me fix this a little bit because I need a little bit more space. Okay, so we have a triangle here. We actually have 3 right triangles. We have the big right triangle. We have this little right triangle right here, and we have this medium-sized right triangle. These problems you tackle by using the big right triangle. This is my big right angle, so this is my most important main right angle. If you notice, that go with that right angle. If you notice, this is the main right angle. Let me do that, identify that for you. That's the main right angle. Okay. The main right angle is the one on the corner of the whole picture. There are 3 lines around that. There is this line. Okay. This line. And this line. Okay. Those 3 lines are all considered means. So this one is actually called a leg of the right triangle because it's not the hypotenuse of the big right triangle. The C right here is also called a leg because it is not, it is the side of the right triangle, not the hypotenuse. And then this side is called the altitude. Okay, we actually skipped a chapter, and the chapter that we skipped just identified what an altitude is. Altitude is perpendicular to the base. So it goes from the right angle here, the point of the triangle, perpendicular to the base. That's what an altitude is. Okay, so we have the 2 legs and we have an altitude. Each one of those are means. So the legs are a mean. And then the altitude is a geometric mean. Okay, so the legs of the big triangle are a geometric mean, and the altitude is a geometric mean. And a geometric mean, we set it up like this. So that means, since there are 2 legs and 1 altitude, that makes 3 things. So we're going to set this up 3 times. So we have this leg that has E. So we're going to set that up here. We have a proportion. E is on the leg. Since it's on the leg, it goes twice. So I'm going to put it twice there. And I'll fill in the other 2 parts in just a bit. We have another leg, which is red. Leg C. Since the leg is the mean, then I put it in 2 spots. And then we have the altitude. The altitude gets its own problem. So we set that up. Goes in 2 spots. And just to show you that it doesn't always have to be this way, I'm going to put it here and here. Okay? So setting up this problem, you kind of have to go. If one of those is a number, then you start with that one. If they're all variables, it doesn't matter where you start. Although you do need to know what both parts are, and you also need to know what the whole thing is. And since we know that this is 6 and this is 24, we can figure out how big the whole line is. So to figure out what goes in the other two spots, it's basically, I call them hops. So I'm going to start with E since I wrote that first. I don't have any numbers shown here where the number goes twice. So since it's only variables that go twice, I'm going to start anywhere, and I'm going to start with E, because you don't always have to go alphabetical order. So since I'm starting with E, E touches the hypotenuse right here. This is the spot where E touches the hypotenuse. And then basically we draw a hop that goes to each other part of the hypotenuse. So from E, always starting at E, because this is an E equation, you start at E. So I draw a hop to this points, the altitude points, okay? And how long that hop is, well, that hop was 6 spaces. So that goes in one of my blanks. Okay, go back to E. So now that I go back to E, because our hops always start with the function we're on, with the side that we're on. We're doing equation E, we're going to hop from E. So if I'm hopping from E, I already hopped here to the altitude. Now I'm going to hop to the end of the hypotenuse. So my hop is going to be this long. So my hop is 6 plus 24. 6 plus 24. Okay, so then I get E over 6 equals, well, 6 plus 24 is 30 over E. So when you cross multiply those, and we get E times E, which is E squared, equals, and then you multiply those, and we get 6 times 30, which is 180, which is kind of nice, because we've already done 180. Since this is E squared and we need E, we would square root. So I get E equals 180. I did up here, so I don't have to do that again. I already know the square root of 180 is 6 radical 5. If I had not done that work, I would do that work now. Okay. C, leg C. Leg C starts here. C touches the hypotenuse here. So that means our hops are going to start from C. Okay, that's our C. Alright, so since this is C, our hops are going to start from C, and the hops are going to tell us what goes in the 2 blank spots. So I hop to the altitude, okay, and that hop is 24 spaces long. So 24 goes there. Go back to C, because this is the C equation. Since this is C equation, you have to start at C. All hops start at C for this equation. Okay, so hopping, we hop to the other end of the hypotenuse, that is 24 and 6 long. I'm going to go ahead and add that in my head because I did it here anyway. So I know that hop is a total of 24 plus 6, so we got 30. Okay, then you cross multiply. So when I cross this way, I get C squared equals, then I cross this way. I want to say it's going to be 720, but I'm not really sure. I haven't done the math yet. So I have 24 times 30 equals, I'm so good. Okay. So I get 720. Okay. Then I C squared. There we go. Square root both sides. Sorry. So I get just C equals, and then the square root of 720. I don't know if that's a perfect square. So let me check if that's a perfect square. Alright, I got a decimal, which means it's not a perfect square. I actually have to figure that one out. So let's do it over here on the side. 720. Okay. You can do 24 times 30, 72 times 10, whatever. I'm going to do 24 times 30. That's 3 and 10. That is 2 and 5. Cross out the ones you done. 24. 6 times 4. 6 is 2 times 3. 4 is 2 times 2. I used 4. I want to cross that out. Okay. So I have the pair of 2's here. I have a pair of 2's here. I have a pair of 3's here. So that's a 2 and a 2 and a 3, and this poor 5 is left behind. Okay, so 2 times 2 is 4 times 3 is 12. Okay, so, and then we get 12 radical 5. So that's the answer for C. So E, 6 radical 5. C is 12 radical 5. They just happens to be twice that. That doesn't always happen. I just kind of made this problem up on the fly, so, you know, it's just a coincidence that that is twice that. It doesn't always happen. Okay, now for D. This is the altitude. D, to find the other two spots, we're going to do the same thing, do hops. D touches the hypotenuse here, so all of our D jumps are going to be from the D line. Okay, so my D hop, my first hop, I'm going to make these hops really small because the other, I don't want it to blend in too much with the other hops. Okay, so going from D, I hop right there. So that hop was 6 long. So I'm going to put 6 here. So back to my D line, because this is the D equation, and I'm going to hop over there, the other direction, and my hop is 24 long. So I put 24 in the other spots. Okay, cross multiply. Cross multiplying those two, I get D squared. I just like doing my variables first. Habit. 6 times 24, so D squared equals 6 times 24 is 144. D squared, to get rid of the square, you square roots, and I get D equals 12. Okay, so I know that's a difficult problem. So we're going to do another one. I have another one. Just bear with me. There. Okay. Okay, there we go. This one. Okay, so remember it's a big right triangle. We're not looking at the little right triangles. We're looking at the main right triangle. The main angle, the main right angle is that one. Okay, main right angle. Okay, from that angle, we have the 3 lines, the 2 legs. So here's a leg. Okay. Leg Z. Okay, we're going to make a proportion. Z, Z. Okay, it goes diagonal to itself. Okay, the next one, the other leg. Okay, that is my other leg. Okay, leg Y. So that my proportion, Y and Y. Okay, and then the other line, because this is the main right angle, there's 1 line, 2 lines, the altitude line now. Okay, that's my altitude. Is 12. Since my altitude is 12, 12 is what goes in the 2 spots. Okay, so now we do the hops. Now I said before on the last problem that you have to look And if any of those have a number, you start there. I have 12. Okay, that's a number. I'm going to start there. That tells me I'm going to start here. I'm not going to start here or here because those are variables. When I have a number, those are easier to work with. You do the easy ones first. Okay, because if you do this one, the hops from Z, you'll end up with a variable or second variable. So you'll end up with X as part of these. And you can't do this if you have two variables. This only works if you have one variable. So, since this is 12, we're only going to have one variable on this problem. This is the problem we want to start with. So we do the hop. So we're doing 12. Let me get the right color. Okay, so my 12 is the altitude. My 12 is going to hop from that spot, okay, from my 12 line. So when I hop to one end of the hypotenuse, I don't know how long it is, but I know it's called X, so I'm going to put an X. Okay, go back to your 12 line because we're doing the 12 equation. Our hops start from 12 line. So hop from 12 to the other side, and I get 9. Okay, that one I can solve. So cross multiply. So when I cross this direction, I get 9x equals, not a fraction, we're getting rid of fractions. 12 times 12 is 144. Notice I don't have x squared. I'm not going to have to square root. I have 9 times x, and the opposite of 9 times x is dividing by 9. So I divide both sides by 9. So I get x equals, and then I use my calculator, 144 divided by 9 is 16. So x equals 16. It's not x squared equals 16. I don't need to square root. I'm done with x. And what I want to do is I want to write that up here. X, write it carefully. X equals 16. So that now when I use this segment, it's 16 and not x anymore. We found x. We replace x with 16 so that when we do our hops, we have numbers for the two places and not a second variable. Okay, so now we need to find z and y. It doesn't matter which one you find first. You can go alphabetical order. You can go reverse alphabetical order. It does not matter which one you do because we have two numbers on the hypotenuse. Okay, so I will find z first. Okay, z, this is the z line. So z hops starts here. Okay, z hops start here. So my hop first to the altitude is 9 spaces for that hop. And then I go back to my z line, z equation, z line. And then I hop to the other end. That hop went from all the way from z to the end. And that is 9 and 16. You add them. 9 plus 16. Okay? 9 plus 16 is 25. So I have 9 over z equals z over 25. Okay? So, cross multiply. Z times z is z squared equals 9 times 25, is that 225? Okay. 225, and then I square root. This one does have z squared, and since it does have z squared, we square roots. And when you square root 225, oh, I think I accidentally squared it. 225 square roots. Oh, okay. My calculator is not working right now. Let's try this again. Square root 225 equals 15. There we go. Here's a key. If you're not really sure how your calculator works, because this calculator is a little bit different than any of the ones I have in my classroom, then just kind of make sure your answer makes sense. So like I square rooted 225 and I got 3,000. I know it should be smaller than 225. It should not be bigger. Or when I got 5,000, should be smaller, not bigger. So I knew to keep trying until I got the right answer. Although I already knew what the square root of 225 was. So I knew what the right answer was. I just wanted to show you. Okay, so that's z. We still need to find y. Let me get my red. Okay, y. Y line. So our two spots get filled with hops. I'm going to do these hops lower. Y line. Oops, sorry. Hard to write this direction. Okay, so the y line hops starts here. So I'm starting here, and when I hop Lena, I'll hop low. My first hop takes me to 16. Okay. So I have 16. Then I go back to my y line. My hop has to go all the way to the z line. So my hop goes there. That is 16 and 9. Okay, 16 plus 9 we already added is 25. So now we cross multiply. Y times y is y squared. 16 times 25 is 400. Okay. Square root both sides because we have y squared this time. We can square root. We couldn't square root for x, but we can square root for y. So the square root of 400 equals 20. So y equals 20. That is how to find the geometric mean on a right triangle. Okay, so you're going to have some problems where you just have to set it up, where they just give you two numbers and you just set it up like this with x and two spots and other two numbers. But you are going to have some where you have to do the hops. So it will help you if you draw it on a piece of paper and do your hops rather than try to figure out what the hops are without paper. Okay, so that is geometric mean. Have a good day.